Hey gang, it's Randy Osborne, your teacher. I'm here to explain this last project that we did. I know it was hard for a lot of you, and I can totally understand that. It's so much easier when we're in class and I can answer questions and I can draw it up on the board and everything. So I thought I'd kind of do that here and show you how we do this. Um, just to make you all feel better about this project, if you participated, you get 15 points for doing the project portion, the questions that were figuring out how many people could be in a room. The quiz portion, you actually got the score of how many you got right. So a lot of you got scores like 22, 23, 24, and you're thinking, well, I didn't even get all of the ones right in the project portion. That's because if you did it, you tried, that was the purpose, to try and do it. But as you know, the quiz portion, I wanted you to get the questions either right or wrong. So here's what we're going to do. I'm going to go back and forth here and explain some of this stuff uh, with the questions and how I got the numbers that I got. So first of all, let's remember we talked about that there's a difference between what we learned in chapter 5, occupant type, and the word use. Use is the answer to the question, what are you going to use the building for? And it's only fair that based on what you're going to do there, we're going to have different rules, because a place that makes chemicals is very different than a place that serves food. We shouldn't have the same rules for them. So based on what you're going to do there, we're going to have different rules. One of the ways we deal with that is by putting the different buildings in occupancy types. So we learned about that in chapter 5. An assembly, an A2 is a restaurant. An I is institutional, a prison or a hospital. And all of that stuff that we learned there. B is just a business. But we have to remember as we come back to occupant load, how many people can be in a room. We want to go back to the term use. What are you going to use it for? So if you look at our table 1004.1, the function of space here is, what are you going to use it for? What's its function? So we're going to ask that question. But the first thing we had to do, remember our formula is the square footage of the room divided by the factor in table 1004.1.1 that's based on the function of the space. So if it was a baggage claim, right here, I'm going to divide the square footage of the room by 20. Now remember, we talked also about the difference between gross and net. Gross is, hey, if this is gross, it's everything in there. We don't portion it out. We don't exclude certain areas of the room in our count. We count the whole building or the whole area. But if we have a net, like in our assembly areas, when we have a net, we're only going to count that portion of the room that is used for, let's say, we use dancing with standing. So if we have a nightclub that has an area that's a bar and some dining, well, that's tables and chairs, and it's going to be divided by 15. But only that portion of the building that is used for dining and serving and eating. So, but now in the other part of the room where everybody's either standing to watch or dancing, we're going to allow that to be divided by 5, but only that portion of the building that's used for the standing or dancing. So that's net. But let's look at a couple of our examples that we had in our egress project. So let me switch over to that. And here was a word problem. Your fire company's been assigned to perform an inspection in a building that was formerly a warehouse. This is very common today with raves and stuff like that. They turn these warehouses into nightclubs. The public area of this facility is a room that measures 100 times 150. Well, okay, how do we get the square footage? Let's bring our little calculator here. 100 times 150. That's how we get our square footage, right? Length times width, and we get 15,000. So the fire marshal, there's no fixed seats. The fire marshal is asking your company to determine the legal occupant load. Well, here's the deal. When we're dealing with a place like a nightclub like this, sometimes they're going to put chairs in there. They're not fixed seats. They're just removable seats. Sometimes they're going to even put tables in there. And sometimes they're going to have standing room only or dancing. Well, in that case, we're going to figure out all three. And that's why I wrote down here standing, seating, dining. So for standing, what are we going to divide it by? Or dancing, right? Dancing and standing are both people on their feet. Though I've seen a lot of people dance and they take up more than 5 square feet per person, but you know, they're just using a general number here. So we've got our 15,000. We're going to divide that by 5, and that gives us 3,000 people. Yowza. That's a lot of people. So you would write the maximum that this building is going to have is 3,000 persons. Okay. Now, if it was seating, we're going to go back to our 15,000 number, divide it by 7. Because this is non-concentrated seating, not fixed seats. These are chairs that are removable. We divide it by 7. I think I did something wrong there. Yeah, no, I think I had something wrong. 2,142. Okay, so that would be for seating, and then for dining, we divide by 15, and we get 1,000. So we go by the maximum. The maximum would be 3,000 people. If we had 3,000 people in there, we have to have a minimum of 4 exits because we have that whole deal of 50 to 500 is 2 exits. 501 to 1,000 is 3 exits. Over 1,000 is 4. Now, you know and I know that's not enough. There's another part to this where they're going to actually use 0.02 as a number that they times the amount of people by, and we're going to end up with more than 4 exits. But this is the minimum. This is the minimum that it has to be. So, and we'll have to make them larger exits and more of them to make sure that we can get 3,000 people out of there safely. So that's a really basic one. Square footage was length times width. We divide it by our factors, and we came up with 3,000 as the most that could be in there, requiring at least 4 exits. Okay, you want to look at number 2? Let's do this one real quick. Now, here's another thing. Let's go back to our, well, let me do this part first. 50 times 75. Ooh, where'd my calculator go? Let me bring it back up here. There it is. 50 times 75 equals 3,750. But we've got 2 portions that are the same size, so times 2 equals 7,500. Now, what's the number we're going to divide that by? This is an industrial building being made for manufacturing. Now, that word threw a lot of you off. So let me go back over to egress definitions. And a lot of you went to, oh, here's the word manufacturing, fabrication and manufacturing. But notice it says H5. That's only used for making of computer chips. So H5 is a place where they make computer chips. So that one doesn't work. It's actually this one, industrial areas, that we should use, which is 100 gross. So we go back to our calculator again. 7,500 divided by 100 equals 75, right? That was our number, 100 gross. 7,500 divided by 7,500 divided by 100 equals 75. So it would have been 75 people, and all that requires is 2 exits. Now, again, we might end up having more exits than that, but that is what was required. Okay, in a manufacturing area, they're factoring in the fact that you are going to have equipment in there. So that's why they're giving you fewer people. Number 3, you're assigned to determine the occupant load on a new youth-oriented entertainment facility. So this is similar to our first question. Building's principal room is 100 by 250. That's a big place. 100 times 250 equals 25,000 square feet. That's the floor area of the principal room. Now, what if it was a skating rink without a deck, just a skating rink? Well, we go back to our egress definitions, and we have skating rinks, swimming pools, rink and pool, 50 gross. The decks are 15 gross, but we don't have a deck. So we're going to go with that number 50 gross. 25,000 divided by 50 equals 500. So the occupancy factor would be 50 if it was a skating rink without a deck, and then we'd get our number of, was it 500? Yeah, 500 as how many people could be there. The occupancy factor, if it was a dance hall, we already know that one, it's 5. So using the highest occupancy factor, well, that's going to be 25,000 divided by 5. And that's going to give us 5,000 people, right? That's a lot. Now, what's the classification of the occupancy? It's an A2. As a dance hall, a nightclub kind of a place. It could be as just a skating rink without a viewing area, without a deck. It could be an A3, but A2 is a little bit stricter than A3, so we're going to go with A2. So hopefully by my going through a few of these, you can figure out how to do this. Oh, by the way, on this one, floor area of the clothing store is mercantile. And this was a little confusing. The grade basement and grade floor area is the number you should use. Grade means bottom floor or main floor. So if it's not a multi-story building, which it doesn't tell us that it is a multi-story building, so we would use this number 30 gross. If there was a second floor and a store on the second floor, then we'd use 60 gross. Okay? So the restaurant is an A2. We used 15 because it's a dining area. And for the clothing store, it is basement and grade floor area of mercantile, so we used the number 30. Okay? Hopefully this has helped you out. Figure it out. This one had a portion of fixed seats, but it told us how to do that. 6 divided by 2, because they're saying there's about 2 feet per butt. That's how they figure it. So 10 feet, 6 divided by 2, or 10 booths, 6 feet wide, divided by 2, so 3 times 10 is 30. Okay, so I just wanted to make that clear for you. Sorry if this was a little long. I hoped it would be under 10 minutes, but it was 14. So thanks a lot. Good job. Keep going.